Hey guys, I'm back. It's been time since my last video, but let's go ahead and get started learning how to start coding. But before we do so, I'm gonna give you a quick little 5-minute spiel on how binary numbers work. As you all know, if you've seen The Matrix or any of those computer movies, there's always zeros and ones that are just flying across the screen everywhere. So what's really happening in a computer is there's a series of zeros and ones, and those zeros and ones are interpreted as instructions that are run on your processor, and your processor knows, based on the instructions from those zeros and ones, what to do with them. Now, this sounds cool and all, but let's look at, first of all, what happens when you have a binary number. So in your processor, if you were to have like a 32-bit processor, you would have 32 zeros or ones as shown right here. So I put them in groups of 4 so they're easier to read, and we'll go into more on this, on why groups of 4 are useful later. This is going to show up in things like hexadecimal numbers. So when you're looking at binary numbers, you start at the right basically, and the rightmost bit, this one, is going to be 2 to the 0th power, right? And then if you were to go over 1, it would be 2 to the 1st power. So whenever there's a 0, it's going to have no value for that 1 power. But if I were to say change it to a 1, then it would be 2 to the 2 to the 0th power times 1. So what happens is that becomes 1 times 1. So this binary number would represent 1. So let's say now that we were to change, say, this one right here. So this is 2 to the 1st times 1, which is 2. So we'll do some examples down here. That is 2. We'll put 1. And then, so if we were to keep moving this 1 down, so like this, 0, 1, 0, 0, that's going to be 4. And then 1, 0, 0, 0 is going to be equal to 8. So here we go. It's like 2 to the 0, 2 to the 1st, 2 to the 2nd, and then 2 to the 3rd is right here. So what would happen if we want to do a number like, say, 9, right? So if we recall, as I said earlier, you can take the number, you're going to be adding up all of these numbers that appear in series of zeros and ones. So a number like 9 would be represented as 1, 0, 0, 1. So what's going on here is it's 2 to the 0 plus 2 to the 1st times 0, which is 0, 2 to the 2nd times 0, which is 0, and 2 to the 3rd. So that becomes 9. So let's write this out in a little bit more friendly form. So let me add an exponent, to the 0 times 0 plus 2 to the 0 times 1, sorry, plus 2 to the 2nd times 0 plus 2 to the 1st, 2 to the 1st times 0 plus 2 to the 2nd times 0 plus 2 to the 3rd times 1. And that equals 9. And as you can see, you're starting to see that there's this pattern forming where like a number like 10 would be represented as 1, 0, 1, 0. and so on and so forth. So this is how binary works, but this is cool. It doesn't really mean anything. It didn't mean anything to me after I learned this in terms of like, how does a computer know what to do with these numbers, what's going on here, and so on and so forth. So in order to like understand what happens with these zeros and ones, we have the zeros and ones will become things like instructions on our processor, and we have a language called assembly, which will allow us to take these direct binary values and do operations with them. So I don't know if you guys are familiar with any kind of circuitry. I mean, if you are, you probably already understand this, but when we have instructions like in assembly, we'll see things like add. I'm gonna make it lowercase, and then it'll be like R3, R2, and R1. This is an example of what you might see as an instruction. What happens here is it would take things in register 1, add them with whatever is in register 2, and store that in register 3. So this is kind of confusing to most people at first. So if you were to take a course on computer architecture in college or something, or just read about it more online, you'll find out that registers are essentially, they're just little blocks of memory, right? So R1 can be just a block of memory, and the size of these guys are specified by things like your what is called an instruction set architecture. So there's like lots of these available, depending on what you're using. So there's like ARM, which is really common for things like mobile devices, and just ARM chips in general, obviously, and then things like your x86, which is what my computer is running right now. This might all seem kind of foreign to you, but I just wanted to show you that these binary numbers will become, you can write programs that will look like this, where they have like add R3, R2, R1, and they'll make whole programs in a language called assembly. Now that you see that we can go from the zeros and ones to assembly, we can even take this another step further and allow programs to be represented in other programming languages such as Java or C or whatever other programming language you want. So if I were to write like code in a language like C, it would take whatever I write and it would turn it into, which it doesn't look like these assembly instructions, but it will turn them into these assembly instructions for me. And then these assembly instructions will then be turned into zeros and ones. So what's happening here is like we've kind of separated the concerns out in programming and made things separate from each other. So when I show you like Java programs and how to do it, it's going to seem like, why did he just show me this? It doesn't really have anything to do with the zeros and ones and the assembly and stuff like that. Well, that's true, but the point is that engineers have used something called abstraction, which will allow problems to be thought of in a smaller scope at a time. So like, you only have to take into consideration a smaller amount of things because you assume that the lower levels of abstraction already work. So this is a really key principle in programming and really key principle in most of engineering. So what we're going to do now is we're gonna go into our Java programming part and kind of explain to you guys what is going on here and how to write your first Java programs. So what we're gonna do, we're gonna do something with your game that we're gonna be making in a little bit. So in Java, we had to think about programs in terms of things like, just in terms of what an object has in them. Like you'll see this in a minute, but Java has this concept of objects. It's called object-oriented programming. Now what this means is I can think of you take nouns basically. So a noun would be like my player, an enemy, and we can get more specific with things like Mario, Luigi, and Goomba. So what's happening here is player is an object, so is an enemy, but objects like Mario and Luigi get a little bit more specific. So this is part of another concept which I'll explain about in a little bit. So each object that we have, like player and enemy, are going to have specific things associated with them. So if you think about what happens in a game like Mario, you have a player on a screen, and he runs across the screen, and there's like there's a background and stuff like that. But that's really not important. We're just going to be focusing on what's happening to Mario, the little player, the little character that you're moving on the screen. So he'll have things like an X position, he'll have a Y position, then he can do things like jump. And what else can he do? He can jump, and then he has lives, and he has a score, or yeah, the score is calculated. So that's kind of, we'll just take score out of it for now. So basically we'll just stick with X position, Y position, a jump ability, and lives. And then maybe we'll give him something like a taunt. So our player can also taunt people. So if we look at this, player has a very generic set of things, right? He can move, he can jump, he has lives, and he can taunt you with something. So, well, let's start looking at this a little bit more. So your X position is like a number, right? So this is going to be a very specific number. Your Y position is going to be a specific number, but jump, what is that? That sounds like a verb. Since it's not a noun like player, something like jump is not going to be an object, but rather it's going to be a method. And a jump is going to be like a series of lines of code that are going to need to be run on your player for him to change his X and Y positions to do something, right? And something like lives that's going to be a number. So, and taunt is going to be something, well, he's going to either do something like a soundbite in the game, but for the purposes of this lecture, we're going to have him just say a taunt on your screen in the form of a console output. So in Java, we need to understand that there are these things called primitive data types. So your primitive data types, there are things like integers, and this is called an int in Java. Integers, and then we have char, which is characters, like A, B, C, D, E, F, and G, so on and so forth. So integers are things like 1, 2, 3. They even include the negative ones and 0, just in case you're one of those math people who's always concerned about where, like what the domain of all this stuff is. So 0, 1, 2, 3, and even things like -1, so on and so forth. So integers are, so it's important to note that they're 32 bits. So what does that mean? So, well, we just talked about them at the beginning of this lecture. 32-bit integer will have this many values, so you can store anywhere from anything from 0 to 2 to the 32. Alright? So if you will store anything from 2 to the 32 numbers that can go in there. So we'll go into this a little bit more, but it also, since it represents negative numbers, we can't just do like 0 to 2 to the 32 in positive numbers, because we also have to have a way to be able to represent negative numbers. So there's different tricks in binary that we can do in order to do that. I'll probably put that into a later video. So there's no way currently to represent a decimal number, like 1.25 or 23 or something like that. So that is represented by a data type called a double, and that has 1 point, just so on and so forth. It's usually practical to keep it to 15 digits of precision. I don't remember the exact reasoning why that is. I just remember having to do this for a programming assignment, and I figured out that the precision was up to 15 decimal digits. So, and then we also have things like float, which are more floating point numbers. They're very similar to doubles. They're going to seem like the same thing to you originally. We're not going to worry about them for right now, but we'll go over them in a little bit. Integer character, float, double. I'm trying to think if I'm missing anything. Oh, we're going to need am I missing any primitive data types? This is where Google comes in handy. We have longs, I know that for sure. Java primitives, yep. Okay, so we have byte. So that is an 8-bit signed 2's complement integer. What does that mean to you? Right now that means absolutely nothing, but what that means is that you can have things like negative numbers. That was what I was talking about with the integer, and maximum. So since it's 8 bits, it goes up to 2 to the 8, right? That's 256. But since we're using 2's complement, we split the numbers in half, and we have negative 128 to 127 inclusive as the range of values that this can store. Also missing short. So that's a 16-bit signed 2's complement integer. So it's -2, the minimum value of negative 32,768 and maximum value of 32,707. Again, it's doing the same thing that this is doing with that bytes are doing. So yeah, integers can go -2 to 31, and maximum values of -2 to 30. Maximum values of 2 to the 31 minus 1. And so those are how you can represent integers. Why would you want to have different ways of doing this? There's like lots of different ways of doing integers. Why do you care? Well, we'll see like shortly that it's sometimes if you want to like use less memory, we would want to use a byte or a short, and so on and so forth. But most of the time, for most programming, you're just going to stick with int. It's just kind of what happens in reality. But if you have something like lives, which goes to like just a 3 or 5, it might be worthwhile just to use a byte. You know, you're not going to have 2 to the 31 lives in a video game. That'll just take forever for you to get to game over. So float. So here's what happens here. So it's a single precision 32-bit IEEE 754 floating point. Okay, so that means absolutely nothing, but what you're going to learn is that the IEEE 754, that whatever the hell that says, is a specification on how floating point numbers work in binary, because I just showed you how integers work, but how would a floating point number work, which is it's kind of interesting. I'll leave that up to you to Google and kind of look at, but we'll look at an image real quick. E754. Let's see if we can Wikipedia, the fountain of all knowledge. Where is an image? There's got to be an image somewhere explaining how it looks. Okay. Sweet. So what we can see here is that in IEEE 754, you have things like your least significant bits and your 8 least significant bits. Yeah, 8. And then there's going to be like a 23-bit mantissa and an exponent, basically. So what happens, and then there's a sign bit right here. That's your most significant bit. So it's kind of confusing to some people, but your exponent will specify like 2 to the what power. So you can have like 2 to the 1, 2, 3, 4, 5, 6, 7 to the 8. And then your mantissa is 23 bits of decimal precision, basically. So this is 75. Yeah, this is 0.75, and then this will represent 248, and the 1 says negative, so it's a negative number. So yeah, that's kind of in a nutshell how that works. So the next primitive data types are booleans, which are true and false values. We're going to use those all the time, pretty much all the time. They're very common. And characters, which do just characters like as text that you're seeing right here. So Java uses Unicode, which is 16-bit characters, which means that there can be like 2 to 16 possible characters, and there are like, you can have different languages because we only need 26 for English, but there's other languages out there that matter, so we can have their symbols accounted for as well. Okay, so now that we talked about this for a little bit, let's go ahead and write some Java code for our player. Okay, so we have x position, y position, jump, which is a method, which would be a series of steps. Lives, which is an integer, and taunt, which is a character, which will have characters in it. Or as we'll see, there's an object that's very commonly used called string, which will contain a lot of characters into what we call a string of text. So we'll see how string works in a minute. And let's go ahead and I'm going to jump into Eclipse, and we're going to, I made a new Java project, so I right-clicked, new Java project, I gave it a name, my name was Hello World. I'm using Java 1.7, you can use 1.6. For this tutorial, it doesn't really matter because we're going to be learning some very basic Java concepts. So if we right-click on our source folder, right-click on your source folder in Eclipse, and if you go to New, and then you go all the way down to Class, so we're going to give it a name, we're going to call him Player, and then we're going to click Finish. So this gives us this screen right here. Let me see if I can zoom in for you guys a little bit. No? There's no zoom here, so let's see if I can find where resource run debug settings, not what I want. Come on. Text? No? Run. So there's a big menu, as you guys can see, and sometimes it's hard to even figure out where your preferences are. It's under Window Preferences. So General, Appearance. Not what I'm looking for. Maybe there's colors and fonts. Okay, I'll be back when I figure out how to make my text bigger. Just give me a moment. Let's Google it. How to make your text bigger, because I can't find it right now. So you go Preferences, General Appearance, Colors and Fonts. You want it to be 24 point. It's better. Very good for screens. Awesome. Apply. So in your cool, we got this nice text. So your Eclipse made you this thing that says public class player. Every Java class that you're gonna write is gonna start off with the word public. Well, pretty much every class. What that is a visibility modifier, and we'll learn more about that later. Just know that we made a class called player. So class is the keyword class, and public and class are both reserved words for your language for Java. So you can't do things like name a variable public, because it will kind of like, well, it's not advised. You probably could, but I wouldn't want to call anything just public, because it would kind of mess with your code readability. And then I named my class player. So it's important to note that every class in Java will be starting off, the first letter will be capitalized, and so if you were to have like multiple words, you would capitalize the first letter of every word. And then we have these curly braces. These guys are important. They specify where your class begins and where the content of the class ends. So the content inside the class will begin right here, line 3, and it'll end after line 5. And as you can see, like Eclipse will highlight the little braces to show you where they're supposed to go. So I like to put them like this. It's just a thing among programmers. Like people like them this way or this way. I just prefer them to be like that. So if we start going through our player and we think about the attributes that we had specified, such as your X position and your Y position, those are both going to be integers. So int. So int is how you would say an integer in Java. And then you have to give it a name. So we're going to give it a name called X position. I'm going to call it XPOS for position. And you put a semicolon after that. So this is how I declare a variable X position. So now nobody else can use the variable X position, right? So it's reserved for this integer only, and no one else can start calling things the same name. So now what happens is we haven't yet given it a value. So if you wanted X position to be 16, you'd have to assign to it. So I haven't yet assigned to it. So if I wanted to give X position a value of like 16, I would say integer X position equals 16, and now X position has a value of 16. but you'll see why we're not going to give it a value in a moment. So you have integer y position as well. That was our other attribute, the y position, and we're going to give it a value of, I don't know, let's just give it a value of 25, right? So we're going to see that they have been assigned values of 16 and a value of 25, right? So what else does a player have in him? So he has a jump method. So, and he has lives and a taunt, right? So I'll get to the method last because that's multiple lines of code. We'll look at that. So first we'll do lives. So let's go back to Eclipse. Integer, again, it's another integer. We're gonna call it lives equals 3, right? Mario usually has 3 lives. Cool. So what else is happening? We also have a taunt. So it's a series of characters and it's called a string in Java. So we have string is the name of the object, and then we have taunt equals go away or something cute like that. So let's look at what we just did here. So we wrote string is what we call an object. It's an object. We're making an object called player right now. So each object has a bunch of attributes like positions or lives and so on and so forth. But what happens when you're an object is it allows for certain actions to be run on you. And since string is one of the objects that comes with the Java language by default. So I'll get more into this after we go about writing our method for taunt and jump and so on and so forth. What other attributes do we have? So we just had jump. Okay. So if we were to go back here, so if we want to write jump, what would happen there is we're going to take our, if you think about it, it'll be pretty simple. It'll take your y position and it will add a bunch of, let's say we add like 25 to your y position or something like that, right? So what happens is jump is going to be what we call a method, and it's going to let you run a bunch of code, and each method has a return type and a name and so on. So we're going to so if you want to write a method, you would do like something like public, and then you have to put in the return type of whatever your method is. So we're going to call it integer, and then the method is going to be called jump, and then you put in a parameter, so, and then it'll take in a parameter. So if you think about this in terms of like math, this would be like having a function where you can pass in a value and you can get out a value from the resulting mathematical operations. So in my jump method, I'm going to have a integer as a parameter, and then I'm going to type it's just y position. We're going to call it y to not confuse you guys for this lecture. And what's going to happen here is we're going to take y, and then we're going to add 25 to that value. So y is going to be equal to y plus 25. So that's how you could add constant value. So whatever we pass into this function, y is going to get a value of its current value. So whatever its current value is, so y would be 25 currently in y position, right? If you were to pass in y position to this function, we would get 25 plus 25. That would return 50 for this one, for this method. So then after we're done with whatever operation we want to do, we're going to then return the value that we want. So it's simple. You just type return and then y. So we will return y. So y is what we call a parameter, which goes up in here. So you can specify a parameter in a method by doing your data type. So integer is the expected data type of y, and your name of the variable, which is y. So if you wanted to also, so we can do int x, int y. It doesn't matter the order that we do them. You can have multiple parameters inside of these parentheses separated by a comma. So if we're jumping, we're not going to really do anything to x. Well, we could also have like things like x equals x plus 0. So this would add nothing to x. But as you can see, we can do work on multiple parameters in our methods, and then we can return whatever we want. So the return value is y, and Eclipse is being so generous as far as highlighting the return type of jump, which is integer. So I'm going to take out this line and save our file real quick. So yeah, this is what our player class does. It has your x position, it has your y position, it has 3 lives, and he can taunt you and say go away. But currently this class is completely useless. And if we were to like try to reuse it in other parts of our program, as our program gets bigger, we'll find that it can't really allow you to do that either. So here's where we're going to want to go back to your variables and not assign them values, and just leave them as being initialized, right? So again, doing just a semicolon after the values, like x position, y position, and lives, will reserve that name for us. And we can give taunt a value such as go away, but we're just going to leave him alone for now. But jump is fine because jump is a method. What I'm going to do is I'm going to move that down in my code, and what we're going to do now is we need to, currently, like if you were to try to create a player, we don't have a way to like give player values for his x position, for his y position, and for his lives. So it would be useful if we could do that, right? So Java allows you to do that by what's called a constructor. Now each object has a default constructor, so the default constructor will just allow you to create the object of player, and it kind of will pass in nothing to it, so your player will have no values, which is no good. So for me to make player a useful class, a useful object, I need to pass in some values for player, and that will allow me to set the x position, y position, the lives, and to set my taunt to something that I would like. So here we go. So in order to do this, this is going to look very similar to a method. So you're going to type public player, and then you're going to put it in your parentheses again, and then you have your parameters. So I have my integer x, I have my integer y position, and then I have my integer lives, and then I'm going to have the taunt as well. So my string is my data type of taunt, and taunt will go there. And then what we do now is we put some more braces, very similar to what we had with our, everything kind of has braces for these public, player, public int jump, and so on and so forth. So I may seem to be going a little faster now. I apologize. Let's explain what's happening here. So you pass in all of the parameters that you want for the player. Now we can actually assign these guys values based off of the values that were passed in. So one thing to know is that whenever you're within a class, you can see the variables that are inside of these braces, right? So player, this constructor can see all of the values that are like declared inside of here, and they're available because they're the braces, and they're kind of available there, right? So player can't see, this constructor doesn't have access to these values because of the braces for my jump method, right? So what we're going to do now is we're going to assign X position to X, Y position to Y, lives to lives, which we're going to see a way to do that. There's a way to assign, because how would the computer know which lives is which? It's kind of going to be like, oh, if lives equals lives, then yeah, I can do that for you, but it won't be what you really want. And then taunt to taunt, because we didn't give taunts like different names. So I'll show you examples of how to do this, and we'll introduce an operator called the this operator. So here we go. X position equals X, Y position equals Y. And we have lives. So what we're going to do is we're going to type this dot. As you can see, Eclipse is doing some fancy autocomplete stuff for me. But if I do this dot lives, that will refer to the lives variable that is inside of my player class. So then if I said this dot lives equal to lives, what happens is lives will refer to the lives variable in your constructor. So I'm going to end my line with a semicolon as usual, and that is how you will. So this operator will, again, it refers to the variable inside of your class. It's really cool. I can highlight it and see it, and then if you were to use it inside of your methods or your constructors, it will, without the this operator, refer to the parameter that is being passed in. So for taunt, we're gonna do the same thing again. This dot taunt equals taunt. So whatever was passed in is going to be assigned to taunt. And there's going to be no return values here. It's just going to assign things to what they want. We could also like do things to our objects. Like we can do X position +1, or if we could always make it 0 by doing equals X minus X or something like that, but we're not going to do anything like that for now. We're just going to have our assignment statements like this. So one thing I forgot to mention earlier, I just completely forgot about talking about it, is that when we declare things like integer X position and integer Y position, these variables are by default going to be of the visibility modifier public. So that's the same as your class player or your constructors or your methods that are here. But what's going on is like there's different visibility modifiers like public and private, which will specify who can see what. So in this case, anyone with access to your player can see the X position, the Y position, and the lives and taunt variables, and they can do whatever the hell they want to them, which is kind of a bad thing from a security standpoint if you were to be like implementing like a bank or some kind of high secure piece of software. So what we're going to do is we're going to we're going to make them private. So what that does is it makes it to where the integer x position is only visible within this class. And for you to change them, you have to use methods like jump, which will allow you, and so on and so forth, to actually manipulate those variables. So we're going to do it again for private int y position, private int lives, and then private string taunt. So what is Eclipse complaining about? The value of, okay, so it's saying that these values aren't being used, which they clearly are there. I don't know what that's all about. We'll figure it out as we go. Okay, so we've declared these variables as private, which means that we can only see them through our class, this class right here, and we can only use them with methods, right? So in order for me to, let's say, get the x positions value from another class, like my game class, which we might make later, I need a way to access x position, and I need a way to access y, lives, and taunt. So this is done via methods that are called getters and setters. So if you want to get the x position, well, let's see what happens. So you're going to make this public, because that's the new visibility modifier for the getter, because you want someone else to access it. So we say that it's public, and then we have integer as our return value, and then we're going to get x position, right? And then there's going to be no parameters needed for this method, because we're simply going to be returning the x position. So I just said exactly what the code is going to look like for this method. So remember your curly braces. I'm going to say return x position, and that's going to return your x position, right? So if I want to be able to set x position, how do you think we would do that? It's kind of an interesting thing here, because we're not going to be returning any values. We could return the new value that we set, but for the purposes of this method, we're not going to do that. So if I type in this method, what's going on here is this going to be public void. So what happens when you return a void object or a void method is that nothing gets returned. So it just kind of does the operation that it needs, and the code will continue on doing whatever it's supposed to. So if I do public void set x position integer x, this will allow me to pass in a parameter of x, and we're going to set it very similar to what we did in the constructor. So this dot x position equals x. So it's kind of another way of using this operator. Like normally people try to keep the names like really different when they're like starting off programming, but I'm just wanting to make sure that I can show you guys how that operator works. And there we go. We just set the x position of the player whenever we want. So now you can see that this code is really starting to take shape, and it's starting to grow, right? So we can keep going and do this for our y position. We can do this for our taunt as well, and we can do this for lives. That's something that I'll kind of leave to you guys to do if you want right now, but I'm just going to go ahead and fill this in, and we'll come back with another video. Public int get lives. It's going to return lives, as we said earlier. You guys will start to see a pattern here. You'll be able to public void set lives and lives, and then we're going to do this dot lives equals lives. Same thing for our taunt. So public string, because it returns a string, get taunt. Nope, this has no parameters. Return taunt. public void set taunt. This dot taunt. And there we go. We have all of our getters and setters done, which is cool. So now we have a just a recap of what we've done here is we have a player object with an X position, a Y position, lives, and we can taunt you right now. So let's save this code and let's go and try to run it. Let's see what happens. So if I run it as a Java application, it doesn't work. Oh, so now what? Like my code just doesn't run at all. It says that the code's okay. What's going on here? Well, this is something that's pretty important to learn with Java. Is that every time that you want a program that runs, you're going to need what is called a main method. So we're going to make another object which is going to allow us to create player objects and have our code run. So let's go click on your default package on Eclipse right up here, right click, go to new, and then go to class, and we're going to type in main. It's going to be called main.java. So you have right here again another class. It's blank. What this main class is going to do is we're going to just simply use it to run our code. So every time that you want to write a Java program that runs, we need a method called the main method. So I'm going to just show you how it looks real quick. It's public static void, which is lots of visibility modifiers thrown together, main, which is the name of the method, and then it's taking a parameter which is of type string, and then it has a name of args, and it has these two little like square brackets around it. So you got to do an opening and a closing square bracket, and then we need to include our curly braces. So what that does is it just declared a main method, and it takes in a parameter of args, which is what we're going to call, it's called an array. I haven't yet shown you that, but it's an array of arguments which will contain like any kind of command line arguments or whatever else you'd want to pass in. For the purposes of these programs, you don't really care about that right now. We'll probably write some programs later where you can pass in things from the command line, and that will specify like what to do with them. So now that we have created our main method, what we need to do is we need to create a player object. So player. So we're gonna give him a name. So if you remember, like every time we do an integer, we'd give it like the int. We'd also give it a visibility modifier. This one's going to be public since we're running it through here. We can do private if we wanted to, but we'll just leave it as public. And we give it a name, such as my player equals. So whenever you make an object, you have to use the new keyword. So you have new. And then you can see how it like lit up for me because it's a reserved word, and then it's a new player. Okay, so you can make a new player, and then we pass in the parameters that are needed to make a new player in the constructor. So if you recall earlier, that is x, y, lives, string, and taunt. So I'm going to put them right above me in what is called a comment, which is done with 2 of these forward slashes, and then we're going to just fill in what we want to have for our player. So if we have x, y, lives, and taunt. So let's put the player at position x 100, We can put him at also at position Y, like 200, and then we can give him 3 lives, and we can give him a taunt. So we're going to give him a string, which is in double quotes, and we can say, "Come at me, bro." So this guy, this player, will say something like, "Come at me, bro." Cool. So what we've done now is we've created a player object called myPlayer with a position 100, 100, 200, 3 lives, and a taunt that says, "Come at me, bro." So cool. So now we can actually like go about doing things with your player. So if you like think about it, we can do myPlayer. Let's see what happens. Because Eclipse does something really cool. When I type dot, I can see things like equals, get class, and we have get lives, get taunt, get exposition, hash code, jump, notify, notify all, set lives, set taunt, so on and so forth. So what you're seeing here is that there are these methods that I'm getting from somewhere else. This is going to be related to a concept called inheritance. And what's happening is this class, myPlayer, is somehow inheriting from another class called object. Well, in Java, every class that we make is an object. So if you think about it, it makes sense that your player should have access to all the things that the object does because it is an object. There's no need for us to rewrite the code and stuff that the object will need because we can just specify it in the object level and only worry about the stuff specific to what a player needs. So we can then do, so "come at me, bro" is our string. So what we're gonna do now is we're gonna write a program that will run, right? So if I run this, it's gonna run, but it's super exciting. There's nothing happening at all. Like I have no idea what's going on. So there's a way for us to print to the console. So let's talk about how that works here. In order to print to the console, we need to use the command system.out.println. Println, right? And then we can type in a string of something, right? So system.out.println expects a string, and you can print out whatever you need. So let's print out "Hello World," which is our traditional program. First thing you should see on your console. Let's do it for tradition's sake. Print main.java is the resources we want to save, and then it says, bam, my console in Eclipse is printed out "Hello World." And before I printed it out, I made a new player, but I haven't done anything with him yet. So if you want to let's print out another line, and we're gonna do myPlayer dot get taunt. So let's taunt us. So now we're gonna print. It says "Hello World" and then "Come at me, bro." So I just did mPlayer dot get taunt. So this is a string that we passed in to your player object, and now we can access him and do things with him, right? So if we want to do something like, so now you've learned like how you can create objects, how you can print things out of the console, and now we can do cool things with them, like make your player jump and set his X position to something else, set his Y position to something else too, and so on and so forth. That'll allow us to move your character around with like things like controller inputs and kind of react to different ways of playing a game and so on and so forth. So there's your common example. So we have the taunt, and now we can also do, let's make your player jump So your player started off at 100, 200. So let's see if we can do this real quick. Show you guys the toString method. So if we do system.out.println my player, oh god, what happened here is something crazy, right? So if we want to have some information on your object, like to print it out for when you're programming and so on, we can specify a nicely formatted string that will show up and that will print out like information about your player. So what's going on here is it says player at, and then a bunch of crap here, which means that's the memory address at which your player is, right? So it's just some random place on my computer. I have no idea where that is, but I know that he can be found here, which is kind of cool. But it's not really useful. But what happened was I printed my player, and the object method has, the object has a method called toString, which will be called on whatever object it wants, and the object toString method returns the name of the class, an @ sign, and the whatever memory address it's located at. So what we can do is we can specify a toString method for player, and we can actually print out useful information like where the player is located at, and how many lives he has left, and something like "come at me, bro," or whatever his taunt is. So if you go back to player.java, you can either click up here because we have both of them open, or if you don't, you can click on the thing on the side in the package explorer. So we're going to go scroll down all the way to the bottom of the player class, and we're going to make a method which will return a string, and it will be titled toString. So public string toString. What is it saying here? We need to add a return statement. No crap, I haven't finished writing the method. So what we're going to do is we're going to return a string which is going to contain all the information that we want. So what I'm about to show you is how we can combine strings together and turn them into something that is pretty useful. So we're going to return lives. No, let's return X position. So we're going to return X colon, and if I do quotes after that, so that's one string, right? And then what I can do is I can add a plus sign, and then I can type your X position. So then I can do a plus, and I have to do another thing of quotes. So if I did the X position there, and then I'm going to type the Y position, but in order for me to make this look nice, I need to add another space because the integer doesn't have a space after it. So then we can type Y colon space plus Y position, and then I want to also add in the taunt. I'll do lives too. Lives colon space plus lives plus taunt colon space plus taunt, and then we have to end this line with a semicolon. So recap, we just typed in a crap load of text, but it's going to return your X plus the X position plus the Y plus the Y position value, lives, the lives value, and taunt's value. So cool thing to note is that every time we do this, so every time we have something before plus, that's going to be a string, and they're going to be smushed together into one pretty long string. And what's happening here is we just have the string X, which we literally said like X colon, like whatever the content of the string will be, You don't even have to give it a variable name or anything. You can just directly do it right here. And then we have things like X position. So what's going to happen is it's going to call toString on the integer, but integer is not an object actually. It's a primitive data type. So it doesn't have like really methods that we can call on it, but the strings know how to handle this. And I'll do the same for Y position and lives. And then taunt is actually a string, so I guess it automatically knows how we should go about printing it in the system.out.println method. So let's go save everything and go back to main.java. And then if we run this code again, we're going to notice that the player, and my player, is going to print out something, what we just said in our toString. So if we do bam, so you have X is 100, Y is 200, Y is 3, and taunt is come at me, bros. This is cool because we just took the default functionality of toString and we overrode it. So if I go back and if I change it, if I were to comment this out, right? So you can do a / and a star, and you can end with the star and a / to do multi-line comments. If I were to go back and if I were to run this again, it's going to print me back the default toString. But since I wrote my own functionality for toString, it's going to allow me to display the text that I want. It's X in X position, Y position, lives, and taunt. So let's save. Let's click run, and then we have this nicely formatted string that we had specified in our toString method. So that's how we can interact with objects. If you want to call, let's try something else. So myPlayer.jump. So we have we can do X is myPlayer. So let's look at what's happening here. This is something kind of cool. Oh, I never made a getter for Y position. Okay. So if we make getters and setters for the Y position, we'll be able to do something that's pretty cool in our on our main class. So I'm going back to player. I'm going to follow exactly what I have above. Public int, get Y position, turn Y position. Then I'm going to have another one right up here. Oh, also, a cool thing to note is like when you're in a program like Eclipse and you forget what a variable is called, you can look right here on your outline and it'll have X position, Y position, lives, and taunt. It'll show you them as little red squares, and then your methods will have these little green dots, and toString will have this little mountain, I think a little triangle. I don't know if that's because of like overwriting. I'm not entirely sure, but it's an easy way to see like what's going on in your class, and you can jump between jump to jump, but you can go between different methods this way as well, and to your variables where they're declared. But we'll go back to the get Y position, so I returned Y position, then we have public int, set Y position, I'm going to do braces again, return, no, I am being dumb, public void, he spotted the error, good job. Y. So this .y position is going to equal y, and cool. So now we have this awesome class again. And if I go back to here, my error should go away, and I have player.jump. So what's happening is we're using functions to be passed in as parameters to a function. It's kind of interesting, kind of crazy. So I'm telling my player to jump, but I'm telling it to use its current X position and to use its current Y position to jump. So then if we do this, we're going to see that the Y position for the player has changed, but in order to do that, we need to print out your player again. So if we can copy and paste this line of code, and then we'll see that my player will have one Y value changed to its new updated Y value. Or not, actually. What did I do wrong here? This is another cool part of programming. Things happen that you don't really expect sometimes. So let's see if I can figure out what happened. So if we go to the jump method, we'll see that obligate jump int x and int y, right? So I'm going to say y equals y plus 25, and it's going to return y. So there's a big problem here. There's a pretty glaring problem in this code that I just wrote. What's important to see is that it's returning a value, but it's not getting assigned to anything. So what's happening is the value returned by jump is going to nothing, essentially. So when I wrote my player.jump and get X position and get Y position, it ran the code happily. Everything happened just fine. It passed in the X position of 100. It passed in the Y position of 200, and then it goes through. So you have X's. So nothing happened to X, but Y equals 200. So 200, like Y equals 200 plus 25 is 225, and it returned 225. Cool. But the myPlayer object, the one that we declared up here, it never had the Y position set to anything. So what we can do is there's a couple ways that we can accomplish this. I'll show you two of the ways that we can accomplish this, and I'm going to settle for one that I see as just easier in terms of that you don't have to worry about it outside of the player class. So if we did myPlayer dot set Y position, we could even be like really crazy and pass in this whole entire thing without the semicolon, of course. We can pass in this entire function call into the set Y position, which is crazy, which is just like, yeah, you don't want to write code that looks like this pretty much ever, you know. It's going to be hard to read. It's just going to not be fun for you as a programmer. But we're going to do it just to show for an example. What is it telling me? Oh, I need to have. So this crazy ass line of code, myPlayer.set Y position, myPlayer.jump, because remember jump returns the value, so we're going to set the Y position to the value returned by jump, and then we're going to pass in the player's current X position to jump and the player's current Y position to jump, and we're gonna have it do something. So let's do bam. So we have hello world, can I grow the Y change here from 200 to 225. So now I'm going to propose to you guys an easier solution. So what if we, instead of having to write crazy lines of code that are really long and so on and so forth, what if we instead just gave jump no parameters and we just changed the Y value? So then I could just say something like myPlayer.jump and pass in no parameters, and I can see him jump. So if we go back to player, I'm going to take this integer and change it to void, So we have it as void. There's going to be no return value. And then I'm going to take out x because we don't even do anything to x. And I'm just going to have the integer y being passed in. Well, we don't even need to pass in integer y either, if you think about it. So we're just going to say this y position. We can do something called plus equals, which would be the same thing as saying this y position equals this y position. Those two lines of code that I have right here are the same thing. So what I'm going to do is I'm going to stick with the one on the top because it's a little bit more concise, but as you can see, plus equals does the current value of the variable on the left, and adds a 25 to it. So we're going to take this out, and we're going to leave it like that. And then we're going to remove this monster of a code line, and then just do myPlayer.jump. So now your player jumps, and you don't have to pass in anything. It's really nice, really concise. As you can see, like all the logic is kept inside of your player class. Anyone outside of it that wants to do stuff with it just says, hey, I want you to jump. So now if I run it, you can see that the value has gone from 200 to 225 in a much more simple manner than before. So yeah, I guess now is kind of a good point for me to stop here. Hope you guys have enjoyed viewing my video and have learned a lot. I'll be back with some more, and we're going to take what we learned here and actually we're going to see if we can go about drawing the player to a screen using the same player class that we have created, and you can even expand upon that some more and add more enemies and other cool ways to interact with your code. So thanks for watching again. Come back in about a week and we'll have another cool video.